So because we had overlapping time and had a metadata activity going on, basically was looking at this information here. I want to come back to this later, and in particular tomorrow. And during the prior demo, we did go through and figure out the basics. And I want to try to reconstruct, if you want to pull out a sheet of paper and try to reconstruct how this is going on with Floyd 3. So we already know that it was designed for a 1 megabyte request that would get grouped across. These numbers are a little bit different here, but I want to try to fill this out, and maybe overnight I'll fill it out for our exact example and send you a copy. So I need to do the direct I/O. By the way, during break, I followed a bug on that panic that we had. I'm being lazy doing everything as root. So we know that the file system was designed for 128K to each spindle, 256 to each LUN, and 4 LUNs giving me a 1 megabyte DMA request coming from the application. So I have a stress test here. Now again, it could be done with DD or other things, but a lot of us are using this SIO command. SIO can generate direct I/O, cached I/O, asynchronous I/O. So there's a lot more flexibility there than, for example, DD. And then I have a script here meant to run SIO in various sizes on various file systems. So first of all, let me figure out, Scratch did get loaded on boot successfully, so I want to do my I/O into /scratch. Let me just bring up a top disk first. Since we rebooted, everything should be quiet. I did want to actually do this with activity in the file system, but that's okay. df-h. So I'm 31% busy, but I still got 2.6 terabyte available. df-i. And I do expect the find command and locate utility to fire this up, but what do I got there? Almost 500,000 inodes on that file system right now. Okay? So tomorrow, instead of generating that data, I expect to have a big slab from LSs and finds on it where I'm just reading data, not writing data. Let's just see after boot how big the slab is. Right now we're at 100 meg. Slab top -S space C. Not a whole lot in there. There's my process table, there's inodes, there's directory entries. And again, these are 1K byte structures, 4K, 2K. So this is a quiet idle system. It's always a good idea to know what this looks like right after a boot. Okay. So I'm going to edit this best.sio. It's just trying to see what shape my file system is in. And I need to do it into, yes, it's going into a /scratch file system. And if I've got the numbers right, 512 blocks should be a 1 megabyte request. And what it's going to do is rotate. And it's going to do direct I/O. The first thing it's going to do is create the file, which means the file is going to grow. There will be allocation for that one. Then I'm trimming memory, and then I am writing to a pre-allocated file, and then I am going to go back to that file and read it. And then it rotates on to cached, and it'll also rotate to async. Let me bring up PM chart before I start. Again, all that system time we had beforehand, and I should do this before we do anything, *W. Look at where my context switching was at the time. And here's where it normally is right now. So I was in the 3 million context switches per second, whereas normally I'm in the 20,000 context switches. These were from the code 5s. This was from the code 2MPs with barrier synchronization problems. And that's what was driving up our system time with perf top. My system time is nothing right now, nothing to look at. So let me best.sio. Before I do that, though, I need to get another window up here because I want to attach to it with strace. I get stitches out of my finger today. So let me fire up this best.sio. It's now running the SIO command. I'm going to do an strace on it, 7386. Okay, my numbers aren't right. My arithmetic is wrong. I've got a 256 kbyte request coming out of this. I want this to match stripe width. So I want it to be in the 1 megabyte range. By the way, let's see what's happening here. I can see the writes that are happening. This was the creation of the file, and then this is the actual writing of the file. And now it looks like we're, hang on here, we're going to get to the reads. And again, for memory, there's no memory pressure here because this is not going through the cache. And now we're into the reads. Now before I go on, let me go into var lib pmcd xvm, oops, var lib pcp pmdas xvm. Run, before I do this, a pminfo-t on x and grep for xvm. There's nothing there. I'm going to start my performance metric domain agent. Let me see if I can get my desktop here. See, I did have some warnings. I wonder what those warnings are. Well, I'm not seeing any warnings anywhere else right now. So now that I did that install, pminfo-t on xvm, now shows my xvm statistics, pm-e grep for xvm, and I have a pmda xvm running. Now, I do not have a PM Gadgets on Windows. There is a PM View for Windows, but it's not integrated into PCP. It's a separate thing you download from PCP from the website. But one of the things I want to do here was PMGXVM. And I can now see and I've got my scratch data and the 4 stripe groups that are making up that file system, and then I also see the log. Okay? Also, let's go back here. I'm just curious, nothing going on there. So this thing is cycling write, write, read, write, write, read, write, write, read. Now let me add in a new tab. I'm going to call this XVM. And let me go new chart. And now that that XVM daemon is running, there will be an XVM thing here. It was not there before. And then I want volume element. And then I want the stripe group. And let's see, I want equal, align, both. Let me go with these. I'm throwing these all in one group. Oh, that's right, I got to do it on a per XVM basis. I'm just wondering if I can select them all here. I'm doing a shift key, got them all at once, added them in, but I had large, 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 4 larges, 3 smalls, equal, unaligned. That looks good enough for me. So these are all the miscellaneous. Now let me go back again, XVM, volume element, stripe group. This time I'm going to put equal, aligned, both. Let me do another chart. Small unaligned. Small unaligned will be what most of them are by default. Let me try another one here. BE, stripe. No, I'm not going to do stripe statistics. Let's do read. So here I can get the I/O on a per object basis, but I'm just going to do a total here for reads, read IOPS, and then the write IOPS. Apply that. I'm going to do another one here on megabytes, bytes, and write bytes. I think I might get rid of that one. I think I'm going to go with this one here. Apply. I want to change that to a stack bar. Oops. So those there, right there, we were in the thousands of range, were small aligned. I don't have any equal aligned both. That's what I'm going to try to hit here. And everything else is coming out small unaligned. Actually, it's coming out, where was that one? Small aligned. Seems to be more the big number that I'm seeing. Let me go into XVM, show-stats, on vol/SCR. Oh, I actually want stripe. So these are the statistics that I'm looking at here. I'm not sure why I'm seeing, of course, we're not looking right now, but there was a burst up here, and I don't know why right now. Again, I still have my workload running. I think that looks okay. I'm going to save my view. That way I don't have to do it all again. Again, file systems are going to change between systems. So if I save it, I can't always reuse it. Okay. Looks like my best I/O is actually done at this point. So I'm going to try this again now. There's the creation of the file. Again, this is burying the noise here. This is where, for example, I might actually change my samples to get rid of that storm. And now I can see, now I'm in the 100 range here. Kind of don't like that. I'm going to change it to stack bar. A little easier to see. So here's the number of IOPS per second. Here's the megabytes per second that I'm hitting. Everything is coming up small, aligned both. Oh, there were some there that were a green, which was small, aligned. Let me go back here. So again, this is too coarse for me, but I changed my size to get rid of the noise, the storm that I had before. Let me go back now to increase my samples more. Try that one. Maybe even more. So there was the creation of the file, there was the write to the file, and now we're into the read of the file. And then after each one of these, so again, everything is coming out aligned, less than stripe width. Now again, I needed to S-trace that thing again. Oh, it finished. Well, anyway, I know that it is the wrong size. There we go. There's another one. Is that the right one? Oh, I know why. SIO actually forks off children, so I need to follow the children. And now I can see the writes that it's doing here. These are in 1 megabyte request sizes right now. Where's the write here? No, I'm sorry. They are still 256K. I'd have to look at the man page to remember what that thing is. So let me kill this thing. And I wanted to change the box size up. again now. They're in 512 kbyte right now. I should have done my arithmetic here. If somebody's got a calculator, I'm trying to do a 1 megabyte request.
But that should be 2048 then, shouldn't it? You're doing basic blocks by the look of it.
Yes, it is blocks.
So 2048 should get you.
Yeah, no, that's fine. I'm glad that you're getting the concept here. I was just going off the top of my head. So let's try running it again this time. And 1812. Oops. It finished too quickly for me. We got here. And now I can see we're at the 1048576. Let me just fire it up again. Actually, before I do that, let me do a BC free-A. Oops. Run the script again. So I am able to confirm that I'm at 1 meg there. But if I bring up top disk, I'm seeing a 256 kbyte request going off to each. That's what we wanted, right? So this is matching the stripe width of the 2+1 LUN that had a 128 kbyte segment size. So that is good, right? We look up here though, I am still not getting equal aligned both. So I am going to go into sys block system, oops, I'm sorry, /sys/block/SD. Oh, we've got a bunch of them here. Hang on. I have a script to save me some time here. Thought I did. Let me see. Get QDEF. So let me modify this. Well, before I do that, /sys/block/XVM-0 is what I meant. Oops. I'm kind of losing my own train of thought here, but block. I was thinking at the individual devices, but what I really need is XVM-1, it looks like. Go into vol info, cat that stuff. This is the data. CD into, I'm in the queue. I'm going to cat my max underscore sector kbyte. There's my 256. That's what we're getting. Okay? But let's also cat /sys block SDA, for example, Q max underscore sector kbyte, and that one is a 2 meg, but XVM is blocking it down before the device driver can get to it. So I am going to cat max underscore sector underscore K byte. Oh, I want max HW. And that one can go up to 4 meg maximum. So I just want to get it to a 1 meg. So I'm going to echo 1024 into max underscore sectors K byte. Again, if I tried to do it bigger than that 40, like let's go 6, it will say I can't write it that big. I'm limited by max hardware sector K byte. And again, dev-attr cannot work on an XVM object. I have a PV on that. So let me try this again now. Let's quiet the system. Run it again. I was expecting to see equal align both, but I am not seeing that. I am seeing the disk writes going on right now. So they did kind of move, but they're still less than stripe width. Let me break out of that. Let's try 4096 just to see what that does. So I'm trying to get the XVM blocking layer out of the way. Not that I agree with that. I'm just trying to make the XVM statistic show something. Engineering says, let the first layer do the blocking. That's fine with me. Run it this time. Still no change. Just waiting for the statistics to come out. So it's creating the file the first time. I'm waiting for this one, stripe equal align both.
Sorry, what do you think the both implies there? What you're saying that is?
This one here, stripe equal align both,
Yeah.
is saying that my request size is matching the stripe width of the XVM file system.
Okay, what's the I don't know. What's the both? What the concept of 2 there? Or what's that? What's the 2? The 2 elements then?
I'm not following you. 2. What do you mean?
Well, it's equal, aligned, both. What's the both? What's the 2 parts?
From the beginning to the end, so we can align to the first drive of the spindle. This one is saying that we are matching the stripe width, and it is aligned to the beginning and the end of the stripe.
Right.
So some are completely unaligned. Most of them are still coming out as the small aligned both. And again, I haven't done this with this release yet, so I'm just looking at changes here. And I basically say these statistics aren't really relevant anymore because that XVM block layer is in the middle. I have a long PV history on this, but we're still getting alignment. Well, not there, but it's not equal to stripe width. We're still coming up less than stripe width there. 2880 requests that were aligned, but still too small. Let me bring up a top disk. I'm not expecting this to affect top disk. And we're still at a 256K, which is what we wanted.
Equally busy, yeah.
Let's see what we got here. So there's the create, the write, and then the read. Create, write, read. And then it flips. I got to be careful here when I'm doing direct I/O or when I'm doing cached I/O versus direct I/O. So some of them, I'm in async right now. Let me just try it again here. allocation block size, huh? Size of the file. Now this is my write size, sorry, that's the size I'm writing. That's the 1 meg. That's at 4096. So I'm definitely not hitting that at all. Now, I'm not going to worry about this right now. I think I just want to move on to my last demo here. But I was trying, normally in the past, I would be able to hit that. This would be the most efficient where it is aligned and equal to stripe width. But somewhere along the way, it seems to be blocking it down anyways. And that's why I was trying to up the XVM. Don't think this will matter either. It's cat max. So that's at 2048 anyways, it's a single spindle. So that's definitely not blocking it down anyways. But bottom line, the thing that matters is top disk showing request sizes for a LUN that match what that LUN is configured for. Okay. I want to do something else now. Let me put that into the background. I'm going to bring up top, type in I. Not even seeing the DD command in there right now. What happened here? Did fire it in the background. I'm going to leave that there. Let's take a look at PCP and PM chart. Now this is, we were doing direct I/O before, now I'm doing cached I/O into that file system. Let's look at memory. And here we go. Now let me get rid of free here. So I am writing dirty data, that's the red there. And there, we just had a flush marked. So at what point was that? 4 gig. Huh. And all that stuff, so it went, and we had some sort of flush that happened here as well. But this data that I'm writing now is going from dirty to write back and then write back to clean. So you can see a flush interval here as it's flushing the data. Let me get rid of this thing here. Oh, I'm in a CPU set too. That's right. Let me break out of the CPU set. Make sure I'm not in the login or boot CPU set. Oh, I wanted to cat it. Oh, come on. There we are. cat/proc/CPU $$ CPU set. So I am in the global now. Oh, before I do that, let's sysctl-a and grep for dirty. So my ratio is 10%. So 10% of 256 would be, I should have 25 gig of dirty data before it starts flushing, or 30 seconds old before it starts flushing. And I should be able to get up to 40% of my memory dirty before the process gets put to sleep. So let me bring up top. Notice the DDs do not have a WCHAN. They are running right now. Let me do an I to get to that. Let's take a look at what's going on here now. That prior DD, it went from dirty to write back and write back to clean. And that's why the clean is constantly growing. And what do I got for time frame down here? I can see these flushes. These flushes look like they're 15 seconds apart. I should be able to get up to half my memory dirty, but it's flushing and doing things a lot less. I wonder if this has to do with CPU sets. Again, this is a new kernel for me. Let's get rid of free. Let's get rid of cache clean. Let's get rid of the slab. And let's get rid of a non-pages and buff mem. And those are the write backs. So we're getting dirty data, and then right here we mark a flush. And it goes from dirty to write back. But then there's another flush here, another flush here, another flush here. And these are happening more often than I'm expecting. They should be 30 seconds apart, or 10% of my memory before flushing actually starts. You got any page activates? That's okay. Nothing going on here. No trims or anything like that going on. By the way, my Newman Link traffic is not working right now. Where's my cursor? Let me get out of here. Link stat-uv-A. There we are. Let's see if that brought my statistics in, and now I can see my link stat statistics. Now there is a hub stats, and this allows me to change and kind of describe some of these things. What is PM Shub? Yeah, PM Shub is there, but it doesn't work on x86 UVs, only on an Itanium system.
What did you install to get them VNCs bringing up a proper desktop there on those big display numbers?
I don't know. I can't answer you right now.
Oh, okay.
I think you were starting a separate VNC server for each display.
Ah,
I can give up my
yes.
display. I'll give up my display. That's fine.
I got ya. Ah, but yes, that might be doing it.
Yeah. But there's a -C option. It's just changed the terminology here, but I can only look at one of these things. And we're looking at Numalink traffic, I think, is the default. Snoop cache, directory memory, the GRU, local home, remote home traffic, but basically Numalink summary is the default. They used to have better descriptions here. So here it's talking about each of the groupings from the link stat. Okay, now I am firing it up. I do not understand right now why there was so much flushing occurring before, but the behavior has now changed to what I was expecting. So all this dirty data is going off the disk, and it's when the flush occurs, and I'm not seeing a flush right now. Let's add a new chart, mem, util, write back, apply. Well, let me change it to a stacked bar. Now, looks like programs are being throttled back right now, and we do have flushes that are occurring now.
That wasn't on the 30-second marker there, was it?
I'm sorry, question?
Yeah, that wasn't on the 30-second marker. It hadn't done anything for 30 seconds there. There wasn't enough memory being dirtied quick enough to force the 40 or 10%.
I agree. And then all of a sudden, it changed.
But it did seem a long enough gap to be 30 seconds or more.
I was seeing them in the 15-second range.
Yeah.
And I agree with what you're assessing. And again, every kernel is a little bit different in this area. I don't know why it was flushing that stuff and then all of a sudden kicked in like this. But you know, every kernel level behaviors change. Now, I don't have any write-back information. This is only when I started the display, so I can't say anything about before that. Now, where are we on dirty data? How much dirty data do we have?
Well, we're doing the 50, 60 gig, aren't we, the 40%?
That's what I'm looking for, yep. But I'm at a 256, so I ought to be able to be in the 100 gig range. But at 26 gig, it should start flushing, and I should be able to grow it into the 100 gig range.
Yeah.
And right now, I've got 64 gig dirty, so there's some throttling going on here. Let's see what top shows me too.
6, 12, 18, 24. So we're...
And notice I do have GET requests going on, which is the IO wait that's visible here. So these things are being put to sleep at this point. Here's my flush daemon that's running, major minor number to that XVM file system. I do have kswapd kicking in too. I wonder what ninfo shows.
Oh, so we can't dirty it quick enough to get the 40% number up because we're always waiting for the GET requests. We can't get it quick enough.
Sleep earlier than I expected. Those sleeps should not be happening until I'm in the 120 gig range. But this is something that I might let Hetty know about, but not something that anybody's going to do anything about until a site hits some problems in this area. Let me try something else here. Notice, by the way, that dirty data was evenly spread across all my nodes because I broke out of my CPU set.
In the full stop calculation, 10% or false the background.
And because I have these spreads set to 1, let me log out, log back in again. Let's see what a sync takes here. So the sync is going to sit there. My file system is actually keeping up with most of this data, but again, I'm not sure why I'm at 64 instead of 120. But you can see the dirty going to clean, and you can see the write-backs down here. Now let me copy /dev/0 to /home/big file. See if I can do that. What's that going to do now?
Home.
Going to copy across NFS.
Correct. But it has to hit the flush threshold. Oh, we're starting to see write-backs backing up now. SSH guest at Floyd 3. That's fairly responsive right now. Come on. And have we now hit NFS unstable? Look at, I'm getting a lot of write-backs because again, I'm writing to a slower file system and you can see the write-backs starting to grow. I can see the I/O wait time going on here. Here's the network interface traffic. I'm looking for NFS unstables. There are some in there. So this write-back should be going to NFS unstable. Now let me add that into this chart. Things are starting to get slower on me. Just see if I get a top. And again, if I log in as guest and SU to root, I'm going to hit all the bottlenecks that I would normally see here. I want an NFS unstable added to this. I'll go F, W, and I can see my, where's the W chan? Let me do an F, Y, let me get rid of some of these things, I, H, O. So these DDs are being put to sleep.
Yeah, that's why it can't generate enough dirty data quick enough, because there's not enough DDs running consistently at the same time. It just keeps putting them on the wait chan.
I agree. And they shouldn't be hitting that until we hit dirty ratio. Oh, I'm dropping data here. I can see the flush daemon is kicked in now.
Well,
my PMCD, by the way, was not running on a global, and it may be in trouble on its own.
well, I'm
Remember, I have a
assuming
login. I came in with this DD. And
well,
this
the GET requests, I'm assuming, are getting something out of the slab for the disk writes.
Not a slab, but it's a kernel routine to get data.
Yeah, GET request. It must be getting a structure from the slab for the request.
I don't think it's a slab request. Let's see if we can. I would want to get into crash. And again, what's my trouble right now? I'm I'm having trouble with everything. What's going on? My CPU sets. When I logged in, I did this within my CPU set, which is also the same node memory for the boot CPU set that I'm trying to log into. My dirty data now has filled up the login and boot CPU set, and everything is feeling the impact now. PMCD is dropping. I don't know if I have a serial console somewhere. I do have response there. cat/proc/$$ /CPU set. This one's in the global, so this one's okay. Node info. I've had a long time PV or RFE to be able to say flush by CPU set. But look at, I'm out of memory in my node 0, and it's all dirty. But I also have a large slab in there too. Now your question, PS-E, let's grep for DD. I put into each of yours the syntax for a crash. I don't know why I have to specify them, but let me just try running, crash, oops. So I'm trying to look at that GET request you were talking about. And again, it would make sense to jump into kernel code and see what GET request is doing as well. That one I'm just going to leave aside. PMCD is basically dead. Okay, that one came back. PS, let's grep for DD. But Mike, this is why I like to run the class on an unknown kernel and then just see what these behaviors are like and watch for trends on them. Backtrace-P, I think on 12921, no P option. So there's that GET request that we were talking about. So what I was trying to say, this is always data. I don't know specifically what GET request is or make request. So here's my write system call that was occurring for DD. It looks like it's a buffered asynchronous write, and it's trying to balance the dirty pages across the nodes. Oh, but we do have a write back of inodes and superblocks being called here, and a write back single. Because the file is growing, maybe the inode has something going on too. I wouldn't say this is going to slab, but I would have to look at those routines. Then we're trying to write the cache pages, initiate an IO request. Here's where we submit the physical, and here's what it's sleeping on. And I'll often just hit up arrow and watch this thing. Here's a different one in a still IO scheduled timeout, but it's coming from balanced dirty pages. Now, what happened to PMCD? PMCD is still there. We rebooted, but let's CD to /proc 295. Let me cat the CPU set one. So that's in the boot. Let's echo 5295 into /dev CPU set /tasks. Well, it did snap back before I actually got that far. So I still have a lot of dirty data. I'm a little surprised still that I don't have a whole lot of write back data going on. and not much NFS unstable at this point. Now, CD to /SCR. Just doing an LS on that file system can take time. Let's see if we can catch that. PS-grep LS.
Interrupt the number of requests on the request. That's right.
If you had a question or comment, we couldn't hear it. Did that LS finish? Yeah, the LS finished. Let me do this now. Kill all DD. By the way, if I'd done an LSOF and grep or /SCR, for example, I would have been able to catch those files being open. So I killed the work, and we can start to see a little bit of flushing here. I wonder if I still have that sync going too. I probably still have the sync command going. So I had an LSOF. Let's just see what that one is. Oops. Let's look for the sync. See what it's doing. Okay, backtrace on 13119. And it is in a write-back inodes situation. There are all the DDs terminated. Let me remove these files. So I can see the dirty, I can see the write-backs, I can see the clean. Since I'm removing the files, the clean portion of the cache, oh look, we got a nice flush going on now. So removing the files, and again, the RM is still sitting there. Again, this behavior is not always predictable, Mike. I've seen it do different things with each kernel as they make changes. But we're getting a lot more write-backs now. We're moving more dirty to a write-back. We're getting rid of the clean. There's another trim going on, or another flush. Again, my RM is still sitting there. I've had cases where the RM comes back right away, but the disk space is not freed up. Can I see the disk space here? There I can see the file system dropping here. Actually, that's not the right one. That's SDK1. That's not the scratch. Let me. So it looks like it can't even do a file system full on the XVM. Can't really see anything there. So I'm not seeing disk space being freed up yet. We're getting down to finishing our flush though. We still have the write-backs to deal with here. My RM has come back now. Not seeing any change here. Let's just watch that for a minute. bottom in the yellow is the writebacks, and when the writebacks are done, but I do have to sort out some writebacks are going to NFS and some writebacks are going to Scratch. 3, 4, 8, 25%. Still waiting for the writebacks. So when we remove the files, we got all the cache clean for them done. The writebacks or dirty was flushing to writebacks. What happens if I do a sync again? So again, direct I/O and raw I/O do not show up this way. Direct I/O will not go through memory. Raw I/O shows up in buffmem. So I've removed the files, the inodes are gone, but I have not gotten the disk space back yet. 4348, and I'm waiting for the flushes to finish. So dirty gets marked by the flush daemon to go to writeback, and as we were saying earlier, it was not behaving as expected because it was flushing like every 15 seconds and below the threshold. And I wasn't able to get it up to 50% or 40% of my memory. What's the disk drive doing? Looks like we don't even have writes going on right now. Of course, this is for disk, not for NFS. So maybe I did get my disk space back on Scratch, but it's home that I'm dealing with now. 58035261. So disk space used is still growing there. Let me break out of this. Well, I can't because it's non-interruptible. Can't break out of this because it's non-interruptible. Let me get out of here. CD to /home. Even CDing into there. There we are. It's bottlenecking for metadata across the network interface that's saturated by the writes. What happened here? My NFS traffic stopped for a little bit, it looks like. But I still have write-back data there. And a little bit of NFS unstable. I've seen this stuff get into terabytes. By the way, once those writes finished, that was through cache, my interconnect traffic went down. So imagine page cache bouncing, spreading data across all the interconnect, and then when the flush daemon comes, spreading it across the interconnect again. That'll tie up the interconnect and everybody feels the impact of that. You can't even get to a shared text that's on another node if the interconnect is busy. Let me just kill this one. I'm going to do something really bad here. I plan on wrapping up in the next 5–10 minutes. First of all, let's see what's going on the server side. Top, interrupt handler, that's what I see there. Ouch, I got a bug here. This is bad. My NFS server does have a performance problem. It is running a GM kernel. Look at the context switching going crazy here. Uname-A, it is not a PTF kernel. This kernel is bad. I do a perf top. Schedule, sched clock lock, return, thread return, finish task switch. This thing is going crazy right now. No. LS mod, grep for IPMI. Huh. Service, IPMI stop. Let's see if that fixed it. Yes, it did. There's a bug in that vanilla kernel where IPMI, which we load into our environment, including ICEs and stuff, that drives the CPU scheduler bananas. Now let's see what top is showing me. So there's the NFS daemons running, the amount of time they're doing, nothing on swap. I do have raw I/O here, but basically 3 gig of cache data. That's cache/proc/mem info. Not a whole lot of dirty, not a whole lot of write back. So this NFS server could be better on, it's not getting enough data to push it up. So most of our cache appears to be cache clean. Let me do a BC free-A. Oh, I don't have it loaded on the system. sysctl-w to kernel, no, vm.drop caches equals, let's go 1. Now let's see what we got going here. My cache was trimmed down by that instead of using BC free. Still have a lot of NFS daemons, sar-d 1-5. But my disk drives are really not showing anything going on. Don't have any of those tools. So everything's looking healthy on the server side. I mean, it's not getting anything from the NFS client. IOStat-x 1-5. DF. My home is on SDA2. Let me do a sar-dp.
Well, home's almost full.
Are we at a full file? Oh yeah, home is full now. Let's remove that big file. That's why the I/O stopped. Good catch. Let's see what, we still have 20 gig of write-back data sitting there. Let me get rid of some of these other windows. Big file is removed now, but I'm still at 100% full. And we got to wait for all this data to flush, I think, before we're going to see that space freed up. What else do we have here? I'm just seeing if I can get some space freed up there somewhere, but I can't. So we're in a little bit of a trouble here. Let me just get rid of some of the stuff. And again, when I talked about the ratio, dirty plus right back, and we see right back here, there, dirty plus right back cannot exceed dirty ratio, but we were seeing it much less than that. This, again, was run within a CPU set. So that's part of our problem right now, that copy to the home directory is contained within that CPU set. Again, I cannot recover memory when it's in a write back or dirty or NFS unstable. We are seeing it slowly go from write back to NFS unstable here. But our NFS unstable is about a half a gig still. And we're not going to get this cleaned up until the flush is done. I think I may be done for the day. Which node is that one? That is all the interconnect traffic for the login node. That's what it looks like for the copy of that home directory that we were looking at. Again, we still see the IO8, but my network interface is pretty much not active either compared to what we were doing back in here. Disks are quiet, but again, all my memory in that particular node. Let's see if I can catch it here. SSH root at Lloyd 3 and info. Oh, I'm not counting dirty. I'm only, the write-backs are not visible on this display. There's only so much space here. I added shemem, but I don't have the write-back data here. Let's see what we can do about that. Sys, devices, system, node, node 0. Let's do a grep of write back on node splat/mem info. And here I can see that node 0 is all write back. And where was our HBA topology? Oh, this is network interface. So the network interface is there on node 0. Actually, yeah, it should be okay. Network interface is within the quick path interconnect off of that, both node 0 and node 1 off that blade. Looks like we had a flush occur where the NFS server picked that up. But again, we're in trouble, like you said, because we've got a fault system full condition. Home is still at 100%. I don't think I want to wait for this any longer. I'm not sure the write-backs will ever finish, since they got nothing to write back to. So I think I'm done. Let's try something else here. PS-E, let's see, we still had the LSOS, we still had the LSs, the syncs, we still had a copy. Let's see, where was that copy? Can't tell what it is anymore. I was looking for syntax on it. Before, I think I'd killed all the DDs, but I didn't kill the copy. I bet that's what's choking us right now. I killed, but I also killed the window it was in, but it looks like it no-hupped or something. So the copy is still there. Let's see. For whatever reason, I can't see the arguments for it. Let's see if we can catch anything about it. But no change right now. PS, grep for copy. Backtrace on that thing. Again, this is what's showing us our IO8. So it looks like it's sitting here trying to exit, trying to close the file pointer, but it has to sync.
Or we deleted the file on the server side.
Correct. But the inode is gone, but the allocator is still dealing with the write-back data. We're not going to recover that space until this write-back is done. And there's nothing for it to write back to. And then it's going to sleep. This is what's counting as IO wait time, and it's going to sleep on a sleep on underscore page. This one counts as IO wait. The other one was for metadata, and that is a down lock typically for load level. So load levels include the IO schedule and the down lock. And there we can see the sleep, the flush. We still have some other things that are all stuck. They're all stuck on the same thing, the NFS server bottlenecked. And the sync command stuck on flushing inodes. I can see a little bit, but not much, not enough to help me here. Let's grep write back in /proc/meminfo. Let's watch it.
What was that trick or command you had that showed the entire WCHAN name instead of it being squeezed all the time?
Fine. If I have the process, I can go into /proc/$, and there's a WCHAN file there.
Right.
But what I was doing was a PS-O for option. Let me do E-O for option, then CMD, WCHAN. That's what you were looking for. And I can grab copy.
That was the one.
Yeah. And then you can see the entire lock name a little bit more. 21527. It is slowly creeping down. 238, 218, 19. The writebacks are slowly shrinking. What about NFS unstable? And that's at 0. So I see just a little bit of creeping going down here. Again, all this being contained within that CPU set. I wonder, PS-E, grep for CP. Let's go into /proc/13162 cat IO. There's the IO is done. IO top, let's see if it still shows up there. I'm not seeing it in IO top because the system calls are done. This would only track what's happening at the system call level. And I suspect that the copy command is still sticking around until the flush is done. Let me do a ps-el and grep for CP. D, non-interruptible state. Let me echo 13162, the /dev/CPU set/tasks. Let's see here. So again, it doesn't know that that PID is there actually. And when I did the ps-ef, I'm seeing it with a bracket. So I thought it might become a zombie or something.
I think it's in an half
zombie. It's not stopped.
It's got to be in an half-dead state, half dismantled, and it's just waiting to flush those last pages, like you say.
Right, I agree. I thought it might have gotten to a zombie.
Until that sync goes, because it's stuck on a page bit, wasn't it? So
yeah.
It's waiting for a page in one of the file ranges that's probably stuck in that sync. So until that sync goes, nobody will go.
Correct. They're all sticking on the same lock now.
I mean, sadly, that poor old sync's gone through every file of the system.
Well, the sync is forcing the flush, but the problem would be the same if I did not have the syncs. It's the flushing that we're talking about. The sync is just forcing the flush. In fact, this one is on the right back. And I can't kill those syncs. This is another reason that you would not want to use the serial console, because then it would become unusable with one of these stuck commands that are in a D non-interruptible state.
So the flush is only flushing on a particular device, 021. What device was that?
Sure. The flush or the sync command would work across the board, but all of our data is going to a particular one.
Exactly. So the sync is the one that's doing it, I bet. What's the device under the flush there?
Yep. So 021.
Yeah.
We don't see it here because it's an NFS. LS- how can I see that?
No, 0 major, wasn't it? 021, wasn't it? What
yeah.
Was it? What, 21-0, was it? What was it?
021, again, this is NFS, not a block device. Let's do an ls-l on /dev.
What was it, 21 or something? I've forgotten.
21.
Yeah.
See if we can find a 021 in here. But I would expect this would be a character device for the network interface. And I don't know what that would be off the top of my head. But I'm sure it's the network interface, but it's a block device. I'm sorry, a character device. Let's go into character. I don't see a 0-1 there either. Let's. It's a good question, and I don't have an answer. These are the major minor numbers. Let's bring up top again. So that is, we are convinced that that's flushing to the NFS server, but I'm not able to see that. Would that maybe be a socket connection?
Can't we see a major 0? That must be.
Good question for Hetty to find out the NFS file system when it's a flush daemon that's going here. LSOF, let's grep for dev. Not really seeing it in here either. Oh, it's a good question. I don't have an answer to find the, oh, here we have some major, well, 04 is for Dev 0. Dev, what was it again? And it's opened by a kernel thread, no process right now, so I'm not sure I can catch it that way either. 021, LSOF, let's rep for 0, 21 for that report. Ah, there we are. That helped us. So we are able to see the bash shells and the LSs, but not the copy. But that's a good question to be able to find major minor numbers in a more friendly way for, in this case, an NFS connection. Can we think of anything else? It'd be interesting to see how long it sits like this before it works itself out. I may have to go into NFS server and try to find space for this 20 gig before it can flush to be able to clean up this whole mess.
The sync will attempt everybody though, so the sync might clear that out and then the flush will have nothing left on its queues to do.
Correct, but it's not flushing because there's no space to flush it to.
No, it's waiting for a page lock, which it can't get because I bet the sync has got it.
Well, I don't disagree with that assessment. We would have to do like a ArchKDB and look to see at the locks and everything.
No, we already saw that in the trace that we did for the flush.
Correct, I agree. Let's take a look at the flush daemon itself.
The data range page.
I'm okay with what you're talking about.
But at least the system's usable. A lot of the time, these people send in stuff where the system's actually gone totally unusable.
Yeah.
So at least the system's still usable.
Unless you log into the boot CPU set, right? Because I think node 0 is still out of memory.
Yeah.
We were going to look for flush. There we are. So again, like you said, they're all on this wait on bit, wait on page bit. In this case, this flush daemon is trying to flush an inode, it looks like.
It is, from that file system.
Uh-huh. And this will show up as IO8 since it's an IO_SCHED_lock. And again, like I say, these behaviors can change as they're tweaking the code, which is why I like to run on a new kernel. But I don't know what else we can do here. Because the server that's trying to suck it up has no place to suck it up to. Let's see. I'm just being real aggressive here to try to free up space and see if that changes anything.
Yeah. But
I had about, what do we got here still, 20 gig? I got 20 gig write back data that's marked to flush. It's trying to flush, but the piece that's trying to take the flush can't take it. In this case, because it's full. Oh, look it.
It's coming up.
So now things are moving to NFS unstable as I free up space there.
That's got it.
But the NFS unstable still has to be taken by the client or the NFS server as well. Let's see. If I try to log into Floyd 3 as guest, keep in mind if I came in as root or came in as guest and then SU'd to root, I would have trouble looking at things too. Let's see. And again, I would not want an NFS directory in my root's default path. So if I log in through the serial console, I don't have any NFS activity. I want to go straight in as root with a very clean path, including things like the SSHD, or in this case, the MindGetty. So here the user's trying to log in, but if I were on another window that was outside the CPU set and everything, okay, now I'm in, let's bring up top. And we can see the data going to a write-back situation now. Did my RM ever finished? My RMs are not finished yet. There we are. Let's do a SAR-DP 1-4. Again, I'm not seeing any disk activity here right now. Oh, there it is. That's the writes that we're doing.
How much disk space is left on there now? How much is free on that now? 20 gig or whatever, 1, 2, 3. Oh, 200 gig.
No, we've still got 19 gig available.
Yeah, 19, 20.
So you can see how somebody can really make a mess, and everybody that's on that NFS path, even just typing bash and the shell has to go off to an NFS home directory, and that data pipe to the NFS server is choked out. But I'm not an expert enough to say what could I have done other than free up space to get the UV back into shape. And I am not a fan of NFS on compute servers like this. How about you, Carlos? Are you okay?
A little tired.
Yeah, I'm pretty much done here. So I was going to have you play around with the buffer cache lab. And Mike, if you're going to do the buffer cache lab, why don't we try it? Why don't you do it on Floyd 2, which is smaller memory and does not have fiber channel on it?
That's that number 9 lab, is it?
Yes.
Yeah. Okay.
And in there, again, it may not be predictable, but I would have, because I was flushing too early and stuff, but you're going to play with dirty ratio, dirty background ratio, and dirty expired centiseconds.
Okay.
And both of you might want to turn off the CPU sets and do it in an open system just to have it more predictable the way the lab was written. Normally I don't turn CPU sets on until Friday, but this week I wanted to run everything within a CPU set. So I don't have anything more to really pursue here. But again, the buffer cache, I was trying to deal with the dirty and the write back. And then I also threw in an NFS unstable, which is when we really got into trouble. And like I said, the file that we're writing to has been removed. The inode is gone, but the space allocator still has to deal with it. Until this write back is finished, then the space will get freed up. Anything else? Well, I'm going to end the demo here.